Okay, so today we're going to look at solving a right angle triangle, finding the sides using our trig ratios. And you all know that if you do have two sides of a right angle triangle, we could use Pythagoras to find the third side, but we're going to look at using trig ratios if we've only got one side in an angle. So to do this, let's just read the question. In triangle FDE, angle E is 90, FD is 14, so that's 14 units, and angle F is 32 degrees. Okay, we're looking for the length of DE, and you can see it's obvious we can't use Pythagoras because we only have one side. So what we're going to do is we're going to use trig ratios, and we're going to use these steps. So the first thing we're going to do is we're going to name the sides. According to the angle you've been given. And obviously not the 90-degree angle, okay? So we've been given the 32 degrees. So in this triangle, we're going to say, well, this would be the hypotenuse because it's opposite the right angle. For the 32 degrees that we've been given, this is the adjacent side. And then obviously the side DE would be the opposite. So that's the first thing we do. After we've done that, we ask ourselves, which side do I want? And which side do I know? Alright, so let's just look. I want DE, which is the opposite. I know FD, which is the hypotenuse. Alright, what do I want? Opposite. What do I know? Hypotenuse. And then we're going to choose a trig ratio that involves those two sides. Okay, so our trig we know, so Toa. Okay, so we need O and H, so obviously I'm going to be using sine. Okay, so we've decided we're using sine because it involves opposite and hypotenuse. So we say sine, and then you look and see which angle did you name the triangle with, and you use the 32. So you have to write sine of 32 is opposite, which is the side you're looking for, over your hypotenuse, which is 14. All right, so we make the equation. And then we solve the equation using equation rules. All right, so we have one term on each side, so we're going to have to get the DE by itself here, which means that we need to multiply both sides by that, 14. So DE would be 14 times the sine of 32. Right, we put this into our calculator. 14 times the sine of 32, and you get 7,42 units. All right, let's try another one, number 2. Okay, so here's another right angle triangle. Sorry, that's a very bad right angle triangle. All right, let's call this one ABC. We're going to make angle A the 90-degree angle. And we're going to say that AB is 42 meters. And that angle C here is 38 degrees. Right. And we're going to find BC. Okay, so again, we name the sides according to the angle we've been given. That was our first step. Okay, so we have been given the 38-degree angle. So hypotenuse, opposite, and adjacent. Okay, so that's your first step. Then what do I want? I want BC, which is the hypotenuse. What do I know? I know AB, that's the side that I've got, and that is the opposite. So again, the ratio I'm going to choose is the one that uses H and O, and again it's going to be sine. Okay, so sine of 38 degrees is going to be sine of 38, opposite, 42, over the hypotenuse, which is BC. Alright, so there's my equation. Now we have to solve it. Now this equation is slightly more difficult to solve because the thing I'm looking for is in the denominator. Alright, so if you are trying to solve for something in the denominator, the first thing that we do to solve the equation is we times both sides by BC so that we can move this out of the denominator. That's the first thing that we do. So now we've got BC times the sine of 38 is equal to 42. Sorry. 42 meters. Okay, now BC wants to be left alone on this side, so we've got to divide both sides by the sine of 38 to solve for BC. So my final equation to solve for BC is that it's 42 meters divided by the sine of 38 degrees. And we end up with 62,22 meters. Okay, 62,22 meters. All right, let's just look back quickly. So I've worked out that this is 62,22. And I always would like to go back and check that my answers are feasible. So in this triangle, we're looking for the hypotenuse, so it has to be the longest side, so it has to be bigger than my 42, and the answer is bigger than 42, so that is a feasible answer. So just check if your answer is feasible or not. All right, let's try one more. Okay, so here's triangle MNO. Angle N is 90. Angle M is 47. And MN is equal to 15 meters. Find NO. Okay, and this time we're going to find it to one decimal place. Okay, so we're going to fill in what we know. We know that angle M is 47. We know this is 90, and we know that MN is 15 meters, this side here. Okay, so step one. Name the sides for the given angle. Okay, so I've been given the 47. So for 47, hypotenuse, opposite the right angle, adjacent, next to the 47 there, and then opposite on the other side, opposite the 47. What do I want? I want NO, which is the opposite. Sorry, not 3. What do I know? I know MN, and MN is the adjacent. Okay, choose your ratio. O and A, those are the two things I've got, opposite and adjacent. So it must be TOA. So tan of 47, because that's the angle that I used to name the sides, is equal to opposite, which is NO, over adjacent, which is your 15. And now to solve this one, it's an easier one again. We're just wanting to get NO alone, so we're just going to multiply both sides by 15. So 15 meters times the tan of 47 is going to be equal to NO in your calculator. And we get that NO is equal to 16,1 meters in terms of 1 decimal place, because I said work to 1 decimal place. Okay, so I've worked out that this is 16,1 meters. In a right angle triangle, or in any triangle, sorry, your sides are in the same ratio as your angles. So the smallest angle has the smallest side opposite it, and the biggest angle has the biggest side opposite it. So if we think of this triangle, if this is 90 and this is 47, then this angle here would be 43 using the sum of the angles in a triangle. So the 43 has got the small side of 15, and the 47, which is a little bit bigger, has got a side of 16,1. So that was just to see if this is a feasible answer, and yes, 16,1 is a feasible answer. All right, so that's how you go about solving these things. Follow your steps, solve your equations, and then find the missing side.